Okay, welcome back to another video on the Math channel. It's your teacher, Mr. Lim here, and in this video we are going to be looking at statistical investigations. So by the end of this lesson, you'll be able to conduct and identify issues with statistical investigations and explain what causation is. So let's have a look at the first one. In order to conduct a statistical investigation, we need to do four things. The first thing is to collect the data. So collecting the data. What that involves is deciding what data do we need to collect, where am I going to find that data, and going out to actually collect it. So this data can be gathered by conducting either a census, which means collecting data from an entire population, so asking every single person in that population the same question, or a sample survey. So collecting data from a smaller group of part of that population. However, the sample must be representative of the population. Otherwise, the data will be biased. Okay, so a good reason why you would want to conduct a census is because it's very accurate. However, it can be very expensive to conduct. That's why most businesses or most people opt to just conduct surveys, but you need to make sure that the people that you ask is representative of the population, as if you had asked everyone. Okay, so first step is collecting the data. The second thing we need to do is to organize it. So organizing the data. This involves arranging, representing, and formatting data. For example, to store and search a large amount of data, the data needs to be categorized. Organizing gives structure to the data. Okay, so this is often found or done in table formats. Often you might see frequency tables, stuff like that. That helps organize and sort the data. After we've done that, we now need to summarize. So summarizing and displaying the data. Okay, so we've collected it, we've organized, now we need to summarize and display the data. This involves the presentation of the data and information. Information must be well organized, readable, attractively presented, and easy to understand. Information is often displayed using graphs, such as scatter plots, dot plots, maybe histograms, line graphs and leaf plots, and box plots. Data summarized using statistics such as the mean, median, mode, and standard deviation. Okay, so we've collected the data, we've organized it, now we need to summarize and display the data in a nice graph that's easy to understand. And finally, once we've done that, we can analyze it. Okay, so this involves examining the data and giving meaning to it. When analyzing bivariate data, the form, direction, and strength of the association is determined. Scatter plots and lines of best fit are commonly used to analyze the data. They make it easy to interpret data by making instant comparisons and revealing trends. Predictions and conclusions are completed by interpolating and extrapolating. The data. Okay, so we've collected it, we have organized it, we've summarized and displayed the data in a nice graph, and now we can analyze the data. So let's have a look at a real life example. James has been asked to complete a statistical investigation on whether the blood glucose level in milligrams per 100 mils of an adult can be predicted from their weight. James performed the following steps. First, he collected the data by accessing the medical data on 20 adults. So if you have a look at this table, there's actually 20 people here. We need to look at this one, that's 10, and this one here, that's another 10. So in total, there's 20, ranging from a weight of 60.2 kilograms to 78.9 kilograms. All right, so he collected the data by surveying 20 adults. Then he organized it by putting it into this table that we see here that I've highlighted on the right. Categorizing the data into blood glucose levels and their weight. So we can see here, when he organized the data, he did it in ascending order of weights, because according to the weight, each person it increases. Okay, it just gets higher and higher. All right. The next thing he did was summarize and display the data. So he took each of these pairs, 60.2, 88.1. So a person with a weight of 60.2 has a blood glucose level of 88.1. That's this person here. And he took each one of these and created a scatter plot. So I'll just highlight one more. Let's have a look at 72.0, 95.7. 72, 95.7 is this one. That's that person there. So he took each one of these people, put it in a scatter plot, as you can see here. And he drew a line of best fit. Okay, so this is summarizing and displaying the data in a nice graph. Easy to see that these dots are forming a trend, an upwards trend. It looks like that as your weight increases, your glucose levels also increase. So James has collected the data, he's organized it, he's summarized and displayed it in a bivariate scatter plot. Now we need to analyze the data. So let's actually work out what Pearson's correlation coefficient is. I'm going to grab out my calculator and scroll back to this table. So I want to be in stat mode. Whenever I want to enter bivariate data, I need to press 2, that A plus BX. I'm going to enter all my X values and then enter all my Y values. Remembering here that weight is the X value, blood glucose level is the Y value. So I'm going to enter all my weights, 60.2, 61.3 equals 63.5, 7, Okay, now I've entered all my X values. I need to enter all my Y values. Just making sure that, yes, I've got 20 values. I didn't skip on any, because here it says my calculator, I should have 20 numbers, and there are 20 numbers to enter for the X values. To enter my Y values, I'm going to press the right arrow button right here. Press it down to go all the way back to the top. And now I need to enter the Y values next to where they are meant to be. So next to 60.2, according to my table, it says 88.1. So I'm going to type 88.1 equals, etc. Okay, now that I've entered my data, I need to press this AC button. Do not press on, AC. And to get answers from my calculator, I need to press Shift 1. Okay, to find the Pearson's correlation coefficient, I need regression, REG, 5. So I'm going to type 5. I want R, so that's 3, equals, and my answer is 0.9507. So I'm going to type in here, R is equal to 0.9507. So what that means is that there is a strong linear association between the two variables, between weight and blood glucose level. Okay, there's a strong relationship between these two variables. Another thing we could do when analyzing data is to work out the line of best fit. Okay, what is the equation of the line of best fit? We're so used to seeing the formula y equals mx plus b. But in our calculator, when we pressed the 2, it said y equals a plus bx. Which means that this a matches with this b, and this mx matches with this bx. So all we need to do is ask the calculator what are the values of this a and this b, and then we can form our equation of the line of best fit. So if we go back to the calculator, press Shift 1, 5 for regression, and can you see here it says 1 is A, press 2 for B. Well, we'll press 1 equals, A is 52.79, and what is B? Shift 1, 5, 2 equals 0.597. Okay, that's to 3 decimal places. So if we were to create our equation for the line of best fit, it'll be y is equal to, or A is 52.79 plus B is 0.597 x. And that is the equation of the line of best fit. So if we go back to the original question, or what he was doing his statistical investigation on, it was to determine whether the blood glucose level of an adult can be predicted from their weight. Well, because we have this equation, it can be predicted. So let's say, for example, we have someone with a weight of, let's say, 80 kilograms. Okay, let's say someone has a weight of 80 kilograms. We can use this equation to estimate their blood glucose levels. 52.79 plus 0.597 times their weight. If we were to put this in the calculator, we get 100.55. So that means we can estimate the blood glucose level to be 100.55 milligrams per 100 mils. Because remember, that is the unit of the glucose. Milligrams per 100 mils. Alright, now we know how to conduct a statistical investigation. Let's have a look at the issues with statistical investigations. So a statistical investigation raises a number of ethical issues, and these include bias. So data needs to be free from bias so that the particular data is not unfairly skewed or gives too much weight to a particular result. A second issue is accuracy. Data needs to be recorded correctly. It is often necessary to compare data from a number of different sources and determine which data is accurate. So right now, there's a lot of fake news out there about the coronavirus and how it came about, and maybe 5G data is causing coronavirus. Check your source. The data needs to be accurate. The third one is copyright. You are not allowed to use or copy the work of another person without their permission. If data is collected from the internet, it should be assumed to be protected by copyright. And the last one is privacy. Which is the ability of an individual to control personal data. Alright, let's have a look at the final part of this video, of this lesson, which is causation. So causation indicates that one event is the result of the occurrence of another event or variable. So this is often referred to as cause and effect. For example, the bell at the end of the period is an event that causes students to leave for the next period. So when completing a statistical investigation, it is important to be aware that two events or variables may have a high correlation but be unrelated. That is, high correlation does not imply causation. For example, the increase in the use of mobile phones has a strong correlation to the increase in life expectancy. However, the use of mobile phones does not cause the increase in life expectancy. So here I've got a link, Spurious Correlations website. It will be in the description below. You can click on that. And if you click on that, it will open this up. And so here we can see that US spending on science, space, and technology correlates with suicides by hanging, strangulation, and suffocation. Right? There's a 99.79% correlation according to this. Pearson's correlation coefficient is 0.9979 to 4dp. So we can see here that it looks like they are very closely linked. But just because they correlate with one another doesn't mean that one event causes the other to happen. It doesn't mean that the more the US spend on science, space, and technology, that causes more suicides by hanging, strangulation, and suffocation. Okay. Here's another one of my favorites. Number of people who drowned by falling into a pool correlates with the number of films Nicolas Cage appeared in. Okay, so it's got 66.6% correlation. Okay, so even though it looks like there is some sort of relationship between these two variables, there's no causation. Okay, the number of people who drowned by falling into a pool was not caused by the number of films Nicolas Cage appeared in. It just looks like there is some sort of association or relationship between the two, but there is actually none at all. Okay, so have a look at that website in the description below. And that's it for this video.